Hey everybody, Mr. Briggs here. Welcome to Geometry. Your fun fact of the day is that the Doge dog, their real life name is Kabosu. Fun fact of the day. Okay, so we're going to be talking about dilations on the grid. And I want you to take a moment and pause and look at what we're expecting you to know, understand, and do by the end of this lesson. If you aren't able to do these things by the end of the lesson, then you should be emailing me or Mr. Bruckman, whoever's your teacher, questions and try to get that resolved. So take a moment, pause the video, read through those. Should have them in the back of your mind going through this lesson. Alrighty, so I'm not going to go through 1A and 1B here because I believe that everybody should by now know how to do a dilation. And I've already done it over here in this tab. I just got to move back over. Okay, so part C is asking us to explain why triangle ABC is similar to triangle DEF. So why is ABC, which is the preimage, similar to triangle DEF? Well, you have to understand what similar means. Similar means the same shape but a different size. Okay? Same shape but a different size. And when you do a dilation is a similarity transformation. If you think back to when we did rotations, reflections, translations, those were congruence transformations. Now we are doing similarity transformations. So the explanation for why triangle ABC is similar to triangle DEF is because dilations are a similarity transformation. But you can also say something along the lines of they have the same shape, but they are different sizes, or that the sides are in proportion, which is what we're about to talk about. Imagine if you took a picture of Doge, right? And you, this is a dilation. Take a moment and pause and see if you can figure out the scale factor here. This is the image, this is the pre-image. These are the same shape. We're mapping between the two eyes and the nose, but they're a different size. We can see the picture of Doge here in all of her glory. It's just getting bigger. It's the same picture, different size. So that's how you really should be thinking of dilations, but think of it as projecting from this point F out. So the distance from point F doubled. The distance from F to C, the distance from F to C prime, that's doubled that distance. Okay? So that's the way that you should be thinking of similarity here. And that's why those two triangles are similar. Okay? The next piece is the asking if the length of AB is 5, determine the length of DE. And this brings up the next piece of dilations. So let me pause the video for a second. Okay, had to open up my toolkit here. Alrighty, so if you think back, the scale factor is equal to what over what? Pause the video, think about it. Scale factor is equal to what divided by what? So the scale factor is equal to the image length divided by the pre-image length. Okay? The scale factor is equal to the image length divided by the pre-image length. So our scale factor in this problem was 3. So 3 over 1 is still equal to 3. We're going to put it over 1 so it's a little bit easier to work with. 3 over 1, the image length in this case will be DE. and the pre-image length is AB. So if we were to substitute in for AB, then we would find that, and we do some cross multiplication here, 3 times 5 is 15, and that's equal to 1 times DE, so DE is equal to 15. And that makes sense. If AB is 5 and the scale factor is 3, then DE is going to equal 15. Remember, whenever you set up any of these proportions, you have to keep everything either image to pre-image or pre-image to image, meaning that you have to have AB to DE, and I'm just following the letters here, equal to BC over EF equal to AC over DF, or the other way around to get the scale factor. Okay? You have to have everything the same. So in this case, we had the image on top, pre-image on bottom. Over here, all of the pre-image is on top and the image is on bottom. Okay? So thinking back to topic 3, pause the video and think about what the perimeter would be if of your image if the perimeter of the pre-image is 14.2. So if you'll remember from topic 3, the ratio of the perimeters is equal to the scale factor. So I've set up scale factor is equal to image over pre-image. 3 over 1 is my scale factor. So I've got DEF, the perimeter of DEF, over 14.2. If I cross multiply, that gets us 3 times 14.2, which is, off the top of my head, 42.6. Okay. And we'd want to say units as well. What about the areas, though? What is the ratio of the areas equal to? The ratio of the areas is equal to the scale factor squared. So if we have image over pre-image for the areas, then it's equal to the scale factor squared. So the scale factor squared would be 9 over 1, because 3 squared is 9 and 1 squared is 1. If the area of DEF, now we're working on top, is 88.5, because that's our image. Again, we want image over pre-image. Then we want to find ABC. So 9 times ABC is equal to 88.5. So 88.5 divided by 9 is equal to 9.8. Okay? There it is. That's all I've got for y'all. So the big thing when you're heading over to the Desmos is keeping things in proportion. If it's image over pre-image, then you've got the scale factor. If it's pre-image over image, then it's just a ratio. If you've got any questions, please, please, please email me. Have a nice day.